Hello student, this is Neyaz Ahmad Khan of DAVCCL Greedy. This video I have brought for the student of standard 9, and in standard 9 the first topic that is to be covered is motion. Motion is a relative term. So first of all, what is motion? To understand this, let us see the definition. An object is said to be in motion if it changes its position with respect to a fixed point. A fixed point, and that fixed point will be an observer, or at the point there will be an observer. That observer records everything, the position change, the time, etc. So to understand this topic, consider two students on their bicycle moving in a straight road. After some time, suppose t equal to at 5 seconds, A asked B, did you notice me? We are traveling, but we haven't changed our position. Initially we were at a distance of x meter, and finally we were at a distance of x meter. So there is no change in position of these two. Either when A checks, the position is of B is x, and when B checks, the position of A is x. So there is no change in position. The position initially was x and finally it is x. So they cannot say that they are in motion. But if I stand here as an observer, I can see initially they were at the position of my position, and they have traveled some distance from me. They have changed position with respect to me. So I am the fixed point, or I am the observer, and I can tell both of them are in motion. There is another example. A and B on their bicycle moving on the same path. A after 5 seconds reaches to this point, and B reaches to this point. So what A can tell about B, that you have moved y meter behind me. So you are, A himself assumes he is stationary and he is the observer, and he notice initially they were parallel to each other, they were side by side to each other, but now B has traveled a distance y meter backward. So B has a motion in the backward action with respect to A, and B at the same time, when B tells about position of A, he calculate that A is y meter ahead of B. So now B can say A is in motion with respect to B ahead of him, ahead of B. So motion is a relative term. So whenever there is some change in the position, suppose that my two fingers are moving like this. So if this finger can say there is no position change, he notice the position change of this finger is 0. So they cannot say each other that you are in motion, but both of them are traveling away or towards me. I can say there is a position change of both the fingers, so they are in motion. But if like this they are moving, everyone can say that they are in motion. Suppose that this finger can say this finger is in motion, I am in motion because I am also changing position. He noticed the change in position, and B also can tell that initially the position of me or my head was this much, but now it is this much. So this finger can say I am in motion. But if I used to tell, then I check the position change of A, this finger, and position change of this finger. So both of them has moved away from me, or both of them has changed position with respect to me. So I can say they are in motion. So motion is a relative term, and only when it will be described if there is a position change with respect to time. Now here we are going to discuss how can we change the position change of an object. So there are two different ways in which you can measure the position change of an object. One type, when you measure the length of the total path between 2 points, it is distance, and displacement, it is the length of the shortest path between 2 points. So to understand these two terms, these two words, let us consider the 2 points A and B separated by some distance, and 3 students PQ are asked to find the distance or displacement between these 2 points. When I asked P what is the distance, he took this path and measured the length of this path and tells sir it is 4 km. When I asked Q, he takes this path and he measured it is 3 km. And when I asked R, he mentioned it is 7 km. So I asked from all of them about the distance, and all are correct here because they have to measure the path of the length they have covered between A and B. So distance, it is the length of the path between 2 points. And displacement, when we ask displacement from PQR, then only one is correct here, and it is Q. Q is correct because he has taken the shortest path from A to B. So Q, the length covered by Q in a straight line is the displacement, and it is the shortest path between 2 points. But you have to keep it in mind that it is a directional quantity. So it is going to be discussed here in the second point. What is distance? It is a scalar quantity. Scalar quantities are those quantities which have magnitude only and doesn't need any direction. They do not need to mention the direction. So distance is a scalar quantity. While when I asked PQR about the distance, they measured the path and they have taken so many different directions and different points, but they did not need to mention the direction. So this path length has a magnitude but no specific direction. It has different direction at different point. So distance is a scalar quantity because it has magnitude, it has value, but it has no specific direction. But displacement, it is a vector quantity. Displacement is a vector quantity because it has to be drawn in a straight line. And if I asked Q what is the displacement of B from A, then he has to start from A to B in a straight line. So direction is A to B. But when I asked Q what is the displacement of A from B, then he has to start from B to A and the direction will be this one. So displacement is the shortest path in a straight line and has a specific direction and from initial to the final point. So displacement can be considered as a vector quantity. Now third point is distance cannot be zero. So if we can see the P went through this path and come back through this path, the initial point is A and the final point is again A. So for the case of displacement, what we do? We draw a straight line from initial to final point. So the initial point is A and the final point is A again. So the straight line will be drawn here of length 0. So displacement can be 0. But distance, it is the length of the total path covered between initial and final point. So the boy P has traveled through this path. So total path length, that is 4 and it was 7 I have mentioned. So 4 and 7, 11 km. So distance can never be 0, but displacement can be 0. The fourth point, it cannot be negative. So distance cannot be negative because here we are not going to see the direction. Whatever the path he has drawn, he has to measure. So the distance is a positive quantity if the object has traveled from initial to final point. But displacement, in case of displacement, it can be negative. For example, if I asked student Q to measure displacement of B from A, then he has to draw A to B a straight path. But instead of measuring, drawing a path A to B, straight path A to B, he draw a path B to A. So the result is negative because he has to measure or he has to draw a line, straight line A to B. In place of that, he has drawn a line B to A. So it was 3 km positive, but he measured it is in reverse direction, so it should be taken minus 3 km. The important point you should keep it in mind distance and displacement are same in magnitude for straight line motion. You know Q has traveled for distance in this path. So the length of this path is called distance of A to B for by Q. But if you ask what is the displacement of B from A, then it is again. So the length in both the cases when you ask for the distance, it is the AB, and for the displacement it is the length AB. So magnitudes are same, but for case of distance it has no direction, but for the case of displacement it has a direction. So distance and displacement have same magnitude for a straight line motion.